But we're here today to talk about synthetic data flywheels for LLM apps. So what you're going to learn is you're going to learn how to use synthetic data to catch failures before you actually launch something to real users. You're going to learn to spot edge cases, regressions, and weak points early using structured synthetic queries. Now, this is what learning that is absolutely useless in isolation. What we're also going to teach you and show you is how to build an evaluation harness to test LLM apps pre-launch. So to automate some testing and validation to catch issues before your users do. And essentially, the way I think about it is we're really working in a space where we've heard terms like test-driven development and all of these things. In machine learning and AI, we really want to think about evaluation-driven development. And my argument, and a lot of people in the space, this isn't novel to me, is that people who've been doing data-powered products correctly have been doing evaluation-driven development for decades now. If you come and tell me Google search didn't have evaluation-driven development from the get-go, then we'd have to take this into the boxing match, or Street Fighter 2 Champion Edition, because I'm from that generation. Just kidding. Then we're going to create an eval-driven loop for reliable LLM development. So figure out how to turn feedback into structured improvement all before launch, okay? And I know this is a bunch to bite off, but I will share a repository of code with you after the fact as well. We teach this in a course, so let's not worry about that for now. I'll tell you a bit about that at the end, but I'm too excited. Let's jump in. So we're going to build a minimum viable evaluation framework, an MVE, which every MVP should have, as far as I'm concerned. So what we've done is built a simple RAG app using workshop transcripts from our course. How do we test that? We think about defining personas in realistic scenarios. Then we generate synthetic questions. Then we use LLMs to generate responses. Then we'll manually label outputs to define correctness and failure modes. Then we're going to build an eval harness using those labels. And I know I'm going through this quite quickly. You'll have time to go through all of this in detail in the next 20 minutes or so. Then we're going to compare outputs from multiple models and then use failure analysis to drive iteration and improvement. What is an MVE? It's a fast, transparent loop for testing and improving LLM apps, even before you have real users. But you're going to want it in dev and prod as well, okay? So how are we building? We're emphasizing clarity and control over heavy abstractions. I'm just going to tell you about Python and API calls, maybe use TypeScript, whatever. The only point is, I love frameworks like LangChain and Llama Index and all of this, but they abstract away a lot of the details. Our good friend Hamel Hussein has a post called "Fuck You, Show Me the Prompt." Part of my language. That's the name of his post though, so I really couldn't get around it. And the argument there is that it's actually, you use tools like Llama Index and it's really tough to extract what the prompt is being sent to the system. That doesn't mean they're not fantastic frameworks to use downstream, but when you're starting to build a relationship with your system, as you start to build it, and build trust with it, which is a key point, you're going to want to use vanilla Python and API calls or TypeScript or whatever it is. In this, I also use custom JSON viewers and simple scripts to expect my traces and iterate. No big brain trusty type thing. Also, wonderful platforms for all of this. I'm not using Phoenix or Rise, also an incredible platform for this. But what you can do is I've vibe coded to spin up custom JSON viewers using HTML and JavaScript. Just for clarity, I don't suggest vibe coding to put things in production, but vibe coding, quick custom viewers like this, incredibly useful. But you need to test to make sure that they're showing you the right things, but it is incredibly useful for these ephemeral tools. And the goal today is really to understand every part of the loop and data before reaching for automation. So what does that mean we're going to do? We're going to start just saying why you need evaluation even without users, what eval-driven development looks like. Going to then show you how to build the eval loop step by step, and then talk a bit about observability and instrumentation in development and production. This last one I'll just say a bit about because it could be a year-long course on its own. So why do you need evaluation? So this is a story that I see all the time and a story that I also have with myself, right? So let me actually talk about my case. In this cohort 2 of the course we're teaching, I was like, how cool if we could all build a RAG system or an information retrieval system over all of workshop 1 transcripts and then workshop 2 ones, because we had lots of guest speakers and that type of stuff, lots of amazing interactions, got a thriving Discord, try to get all the Discord in there and then build a RAG system over it. So I'm like, I've got docs. And then I'm like, oh, maybe I build a retrieval system. That could be useful. Let's add an agent if stuff's not in there. And this is a story people come to me all the time with, whether they're working in ed tech or climate change or whatever it is. They're like, we've got this entire corpus of docs. We want to serve it to users and we've built an MVP. And then they say, does it work? Or, and this happened to me last week, I was like, oh, Gemini 2.5 just dropped. I want to switch out my OpenAI model to Gemini 2.5. And I was like, with both these questions, how do I even test these things? Does it work? And can I switch out an embeddings model or a different generative model? How do I even test it, right? So that brings to mind, oh, maybe I want test driven development. But tests work very differently in the LLM and AI space, right? So what I ask people and myself to do before stepping back, we haven't even specced out a product yet, have we? And this is what most people do. They're like, I've got this exciting thing, let's put LLMs on it and generate some stuff. And there, people always say, oh, I'm using LangChain, I want to do some multi-agent, multi-turn conversation stuff. And I'm like, whoa, what is the goal of this product? Who will be the user? In what scenario will they use it? The answers generally are, oh, we haven't really thought about the end goal. The user, they usually say everyone, internal, external. In what scenarios will they use it? People usually say, oh, I'm not sure. So my gentle encouragement to stop you all failing consistently is to say, answer these questions immediately, even just to get a brief idea of what your answers will be. And you can actually start a data flywheel and build an MVP and an MVE, minimum viable evaluation loop, before launching. So how do we do that? As I said, what you want to do is you want your MVP. Let's say you've got an information retrieval system or RAG system. You can generate synthetic user queries, and I'm going to show you how to do that once you have the users and scenarios. Then what you're going to do, a lot of people are like, hey, can I use an LLM as judge? We'll get to what that is in a second. Can I automate the evaluation framework? And the answer is just look at your data and label things. Like, seriously, let's talk about Crew AI and Studio Ghibli later, and let's label some things by hand, because essentially, what is machine learning good for? It's good for stuff that humans do and don't want to do a lot of, but we need a lot of, or we can't do a lot of. So you want a minimal viable product, synthetic user queries, label some things by hand, then use the label data to build an evaluation harness. And I'll show you how to do that. So this would be some sort of test set and maybe an LLM as judge. Then you use this MVE to evaluate and improve your MVP. Maybe you switch out a different model or a different chunking strategy or different embeddings. And with respect to your evaluation harness, performance improve. Now, machine learning engineers and data people might say to me, whoa, Hugo, whoa, we've been doing this for years. And I would say, if you've been doing your job well, you definitely have. Evaluation driven development is not new. We've been doing it in ML for years. Slightly different. You have an MVP, you collect data, you label responses by hand, you use labeled data to build a basic evaluation system, then you iterate. One of the big differences is, in this case, getting an MVP with classic ML actually involves a lot more work. You don't necessarily get a flashier ML demo right away. You need to hand label a lot of data or use someone else's data. And we've all seen how that can end up. So, Nathan, this is something we've talked about, how a lot of the flavor is different, but the general principles aren't new. I was just wondering if there's anything you'd like to add from that, from your experience, or anything you're working on at the moment.
Yeah, a couple things. And for those that are coming from like software development, there's this thing called the test-driven development, which is deterministic in nature, but also in developing AI systems where there's non-determinism. One thing to keep in mind is just because you've run the test suite once means that maybe next time it'll pass. There might be that 1% or less case that I see quite frequently. So as you're thinking about designing this in these kind of like feedback loops, think about running it more than once. And then also, if your kind of use case lends itself to structured data outputs instead of just a big blob of text, maybe you have a summary bit of text and whatnot, you can use that to further go down deeper into the data and have granular instead of a kind of like a judge or AI approach, write some unit tests, write some filter functions to say, hey, have this passed or not. There's a whole bunch of tools. And as Hugo kind of mentioned, LLM judge is very powerful, but there's also another LLM call out there that by its nature is also a little non-deterministic as well.
And that's a great point. It also can be prohibitively expensive if you're trying to, like, we all think single API calls, cheap, scale them, whoa. Also, to a sub point of everything Nathan said, like aligning human evaluation with getting your judge aligned with your own evaluation is highly non-trivial. Eugene Yan, who I'll link to when I send a follow-up email, has some wonderful blog posts on this as well. But I just wanted to, before we jump in, I just wanted to make clear that It's not that different. But the workflow there are moving parts that are slightly different. The focus will be slightly different. In ML, you collect real world examples, label outputs by hand, or get someone else to do it. MTurk, right? What they originally marketed as quote unquote artificial intelligence in wonderful tech cynicism. So you label outputs by hand, then you train a model on labeled data, then you evaluate on the held out test set, then you iterate based on performance. With LLM apps, we can synthesize realistic user queries from personas, pre-launch. We can label outputs by hand. We can prompt the model and tune the prompt and the system setup. Then we can evaluate using the MVE, using a test set and some sort of automated evaluation. As we'll get to Nathan's point, you can use making sure you get the correct structured outputs. There's one example where we'll get to it, but you expect certain strings in the output. So you can literally do string matching instead of doing LLM as a judge or fuzzy matching. Then you iterate based on performance and use the eval harness an eval harness, that's just a fancy term for an automated evaluation system. And what we'll see is you can do it with something as simple as a Python script, like a 100-line Python script in this case, which I'll share in the repository. The takeaway here is that both workflows are grounded in test sets that that are hand labeled, right? That you have a sense of what's happening in there. Iteration and failure analysis. So now we're going to build the evaluation loop step by step. Now, how do we do that? You build an MVP. You want to evaluate based on, you can first do it on vibes. That means just looking at it, right? And being like, oh, that's cool. Oh, that's a bit weird. Oh, that was a hallucination. You can do it based on more robust error analysis, or you can build an eval harness. And we'll talk about all of these when you're doing, and then you iterate. When you're doing this, the questions you ask initially: who is your user? A one-page product spec, my people. Who would have thought product management would be important when it comes? Of course, I'm being tongue-in-cheek, but who is your user? How do they use the app? Then we create some realistic test data, okay? And then we want to go to evaluate a structured evaluation, not just from vibes. And don't get me wrong, vibes are super cool. I build things at the start using vibes all the time. But at some point, if you want consistent, reliable software, and that, by the way, I just want to make clear, there's lots of new types of software you can build that aren't consistent and reliable. We're talking about building stuff for businesses that need reliability. Okay, just to be very clear. If you're doing it by vibes, you get subjective feelings that seems better. You get inconsistent evaluations. You don't have historical baselines. You can't communicate results clearly, and you can't maintain consistency across team members. And by team members, I also include you on a Monday after doing a vibe on a Friday. Whereas with eval harnesses, you've got objective, measurable metrics, repeatable, structured evaluation process. You can clearly track improvements and regressions over time. You can document your results. You can use LLMs actually to generate documents from your eval harness, which is super cool. Super easy to share and analyze, and you can standardize and reproduce them across team members. Having said that, I'm not talking about building something like super robust and intense at the start. I'm talking about a minimal version of this that then you can use to bootstrap the rest of your system. And so the way we're going to approach this, what do we want to cover in our harness? Of course, we want to think about user and business metrics and tie micro level calls to macro level calls. So we have a project in the course which ingests LinkedIn profiles, and the goal is to automate email outreach to relevant people for positions you have based on their profiles, right? And with LLM calls, a lot of AI engineers are like, oh, is this call correct? Is it grounded enough? Is the precision and recall enough? I don't care about any of those, right? I do when I'm doing technical stuff, but what does the business care about? The business cares about, if you're automating email outreach, that you get better candidates more efficiently, right? So making sure that all of your technical metrics are tied to the business metrics. So you want that in your eval harness. You also want to think about accuracy of their system, of your system. I'm sorry. And by accuracy, I don't just mean the technical accuracy, whether it's precision or recall or F1, however you're measuring the performance of the system. And the other two things are cost and latency. Time and money, people, time and money. The two most important things to nearly all of us, right? So once we have this way to evaluate it, we want to compare, we want to label some samples ourselves to have a test set, and then we want to compare an AI response to that. And as we've talked about already, we can do structured output testing, string matching, fuzzy matching, and LLM as a judge. And I'll show you what the judge looks like in a minute. So now, this is some of the code that I'm going to share with you afterwards, but I'm just going to show it in the slides now. So what I did in my project to create an information retrieval system based on all the transcripts from cohort 1 of our course I was like, okay, I think a data scientist is one persona. I think a machine learning engineer is one persona. And I've described both and given them different goals. I had a third one, which was a beginner student to the course. We can see I've included a few things like, so a data scientist with strong analytical skills, intermediate ML knowledge who wants to incorporate LLMs into their data analysis workflows and posts and projects. Technical level, goals, implement LLM powered solutions for data analysis and so on. Technical level. So I've given a bit of context here, and this is something you can iterate on with your system as well. Once we have our potential users, let's define some situation. Like, let's not stay with that. This is like basic product, right? What scenarios would they want to use it in? A student in the second cohort trying to evaluate their own implementations and understand what makes a good response. They attended workshops on LLM apps, RAG, and prompt engineering. We also have exactly the different types of questions they may ask. They could ask a general question, questions about fundamental concepts, terminology, principles of LLM-powered applications. They could ask a technical question about implementing specific components. They could ask a factual question. Now, the reason I've done it like this, I just want to cover a bit more surface area than in my test harness, eval harness, than I would with the same types of questions. Now, what you want to think in the end is this is about what the data generating process is. What type of questions do you expect users to have? And you could even build a product that if people ask questions that were too far from these, you'd say, oh, I'm a conversational AI assistant that answers these types of questions. For the one you asked, you need to go to X, Y, and Z. Or maybe we'd have an agent come in and try to answer that. Heaven forbid. But once you start rolling out this to actual users, you want to make sure quickly that your synthetic data, what type of input data drift you have there with respect to actual questions. So we've defined personas and scenarios. How do we get the questions? In a for loop over these, and I'll share this in the repo. This is not magic. I mean, it is, but it's easy to do. It feels like magic. I can do a for loop over all those personas and scenarios and generate as many questions as I want. I can as many potential user queries as I'd like. So now I have my personas, my scenarios, and 20, 50, 100 queries, however much I want. And I just want to give you a few examples. So this was the synthetic data scientist technical question 2. Can you provide insights into how to generate synthetic data for training LLMs, especially in scenarios where labeled data is scarce? Great. That was a technical question. Then there's a factual one. ML engineer. What metrics should I focus on when evaluating the performance of my LLM applications to ensure they meet production standards, etc.? Okay. I will just note that I don't think this will be an issue, but my LLM spidey sense tingled when I saw, can you provide insights? I don't know anyone who says, can you provide insights besides an LLM, to be honest. Having said that, it probably won't perform that badly there. So now I've got all my queries and then I can run them through my system, right? Whatever first MVP I've built, I can run them through my system and get responses, okay? And what I did, I vibe coded a little JSON viewer, which I'll include in the repository, which I can just load in the questions and the OpenAI, the GPT 4.0 responses. So here we have the question, what are the first principles for building LLM applications? Then here, the first principles are as follows: focusing on workflow, iteration, hands-on development, building production-grade systems that scale, providing a practical first principles approach. So this is okay. It's not the best. I'd probably give this a pass and say a few things about it. And what I do is I literally give pass or fail, give a reason, save the evaluation. Then when I create an LLM as a judge, I can feed it all of this labeled data, right? So in my app, I save evaluations, each individual one, then I click save evaluations up top, and I can do it with any files. Now, this is an interesting example. Who were the instructors for the first workshop? They were Hugo, me, and Stefan, my co-instructor. This is an example where maybe you don't want to scale to LLM as a judge, right? Maybe you just want to see, were these strings in the response, Hugo Bowne-Anderson and Stefan Krocek, right? So you want to do some string matching there because that's all you want there, essentially. So once we have all these logs, such as pass and fail and the reason. So I usually do this in spreadsheets, but I wanted to show you how to do it in a JSON viewer so I can give you the code. The way I think about this is you log traces in a spreadsheet, prompt and response. Then you add columns. I just added pass or fail and then a reason. You add an accept or reject response, then a reason for accepting or rejecting. And then you classify the failure mode after that. Is it a hallucination? Is it a retrieval error? Is it a format issue? Then, and people hate this. People hate this when I come and say, don't ask me about LangChain. I'm going to tell you about pivot tables because this will help you so much more than LangChain right now. If you then have your failure column and you do a pivot table and rank your failure modes by frequency, by how frequent they are, you can see hallucinations 40% of the time I need to fix that, or retrieval issues 50% of the time. And you're like, oh, wait, I need to fix my retrieval before my hallucinations. And all we need to do this, and I'm not trying to minimize anything, but all we need are our traces in a spreadsheet. Okay, we don't need these fancy evaluation tools, which we will get to at the end. But what we have here is a way to turn our logs into fixes. So this is one example where, let's say the input is summarized doc and the start of the output is dogs are cool, but the ground truth is the start is company report summary. Then I'd give that a fail and call it a hallucination, okay? Similarly, you can see a bunch of failure modes here. Certain ones we accepted. Once you do a pivot table, hallucinations 30%, retrieval error 25%, and so on. So let's say you saw a bunch of incomplete responses first, then you decided to work on that. That would give you at maximum 20% lift, whereas working on these two would give you potentially 55% lift, okay? All that having been said, how then do we use our labeled data to build an eval harness? And remember, all an eval harness is a reproducible script that I can run to get some report of evaluation when I change my system. So we've talked about you can do it with structured outputs, string matching, fuzzy matching. Because of the nature of the problem I was working on, I used LLM as a judge. And this will be in the repository I share with you all. And this is the function. I've split it over 2 screenshots. I'm sorry, just because the print would have been too small. But the prompt I'm giving this simple LLM as a judge is, you are evaluating the output of a RAG system for workshop transcripts. Then I add the question. Then I add all the good examples and all the bad examples. And then I say, new system response to evaluate. A response is acceptable if it directly answers the question with specific details. It is factually correct based on the workshop content. Now, this is something I might want to fix. Remember, this is my first iteration of building an LLM as a judge, and I haven't actually given it the workshop transcript, so it won't know that. And the astute learner here will say, Hugo, your evaluation so far, you didn't even look at the sources in the RAG system. And I would say, you're absolutely correct. We're actually, so far, we've only evaluated on the correctness of the output, not on if it's grounded in the documents. And that would be the next step in, or one of the next steps in your evaluation harness. But essentially, I give it positive examples, negative examples. You could choose to give it a subset of them that are more relevant toward the question being asked. And then I give it some evaluation criteria, saying when it's acceptable, when it isn't. I realize we're nearly at time, got a few more slides, but I'll show you what comes out of this. So I did this, and once again, I spun up a JSON viewer where this is the question we saw before, and we see the OpenAI response and the evaluation, and then the Gemini response and evaluation. Now, I should say I need to fix some of the labels in this JSON viewer, I think, because it should say OpenAI response and OpenAI evaluation, Gemini response and Gemini evaluation. So I'm having GPT-4o as a judge on both, okay? And this inconsistent judgment should change. It's the fact that one's correct and one's wrong, essentially. So what we'll see here is that OpenAI said, so how can I approach prompt engineering? According to Workshop 1, prompt engineering can be approached by logging inputs and outputs, evaluating logs, using API knobs to reduce variance. That all sounds good. Why did I give it a fail? Why did my judge? Okay, so the response also fails to address key parts of the question by not aligning with specific principles in Workshop 1. The judge wouldn't know that, because I haven't given it the workshop. So this is a judge that isn't quite aligned with how I do it yet. So I would iterate with it and the prompt to do that now, right? And similarly, yeah, so this gave it a pass, and I would have given that a pass as well. Now, I also want to show you something wacky happened. I hit my Gemini rate limit through this. This happens all the time, right? So what's my error mode here? And I literally didn't get a proper response. So I need to figure out what's up there. And I don't have a slide of this, but I did build a dashboard where you can see accuracy and cost and latency and all of these different types of things there. But this is how to get a sense of how your system's working and then to iterate. And what you'll see is that Gemini actually got 65% hit rate based on the LLM as a judge based on my hand labels. OpenAI got 70%, But with these types of errors, if I'd fixed those, I think I could have got it up to 80 or 85%. So that would say, based on this basic evaluation harness, we'd want to use Gemini. Now, maybe something we can chat about at the end, I'll foreshadow. And Nathan has a lot of very important thoughts and opinions and practice on this. But I've just generated one response for each query and one LLM as a judge because of the stochastic nature that given an input, you can get different outputs and the flip-floppy nature. Perhaps you want to generate five responses to the same query and check that out and even judge something a few times when you're building out these early parts of the system. So this is out of scope here. I've showed you how to build a basic LLM as judge based on your own hand labels. Aligning LLM judge with your own evaluations is incredibly important. And actually, Philip Carter at Honeycomb, when he worked with Hamel Hussein from Parlance Labs and Fast AI, among other things, what they did is they actually had Philip would go in. They built it was like text to honeycomb query, kind of like SQL, just so not a multi-turn conversation. Literally, you say something, what you want your query to be, and it tries to give you honeycomb query language. And what they did is they actually had Hamel put in a spreadsheet all the LLM as judge responses, and Philip would go and critique those and write his own responses, and they'd create a new judge based around that in order to align human and judge. And sorry, I think I said this, I'm not sure, but I think that LLM was the first LLM put in a production use case outside the AI labs in early 2023, I think. So
I just want to add on that a little bit. So
please.
as you're thinking about building out these like evaluation harnesses and your initial take at it, my advice, save everything that you generate, even if you don't evaluate it. And that could be for like generating content, but also the outputs from the LLM as judge. You save those, and as your product grows and develops, right? Maybe you want to shift tone or how things are answered. You can go back and use those previously generated synthetic outputs, or maybe realistic at the point, to go and continue to refine and maybe find some of those edge cases for that needle in the haystack, that 1% failure mode. So that's just some advice there for building the groundwork with your minimal viable evaluation harness, and then going into phase 1 and 2 and 3 after that initial piece is out.
That's so important. And thanks for that extra clarity, Nathan. And so that really speaks to the versioning story. And this is like, I said that LLM powered apps, similar to ML, some differences, some different textures and colors. And the versioning story actually is where things change. You do want to version everything clearly. And to Nathan's point, you want to have it in an accessible way as well. So you can go back and trace lineage and see what prompt resulted in which judge and all of these things. But in all honesty, versioning all of this types of quote unquote unstructured data in conversations and agents and that type of stuff is actually far more nuanced and tricky than versioning. Let's say if you use tabular data and XGBoost to do like a fraud detection something, right? Versioning that was tough enough, to be honest, but this introduces a lot more. And that speaks very nicely to observability in development and production. So we've already talked about the core loop, right? To evaluate LLM outputs. Just a bit more flavor about how we think about this. For we've got a user, we've got a front-end UI, then we have some LLM system API, right? We want to log everything. We want to log system prompt, user prompt, tool calls, function calls. On this side, we want to log LLM outputs, structured or unstructured, token usage, errors, hallucinations clearly captured, latency, cost tracking. These are things that we want to make sure we log in development and production, right? Now, why this matters is that this allows us to go from all our raw logs to metrics that matter. So we log, we can monitor, observe things. Once again, when building out an MVP, I've been doing it in JSON. Then I moved to SQLite databases. I use Simon Willison's tool, Dataset, spelled DATASETTE, to quickly, it spins up like quick SQL data viewers that I can check things out. And so once you log and then have basic monitoring and observability tools, you can begin to actually track and optimize cost over time, inspect accuracy errors, visualize your latency trends, and make sure you're on top of your user business metrics. So just to recap what we've done before this, it doesn't even matter that it's a simple RAG app because I didn't show you the app. The app itself wasn't of particular relevance here because you could switch any app in and out, right? So I'd build a simple RAG app using workshop transcripts. And this is actually something we're going to build in the course together. So that's why I didn't want to show all that code as well. We're going to build and iterate on. We're going to build an LLM app with LLM material that you can query about LLM app stuff in an LLM app course. So that's LLM appception. So we define personas and realistic scenarios. We generated synthetic questions. We used LLMs to generate responses. Then we labeled the outputs by hand, didn't we? To define correctness and failure modes. Then we built a basic eval harness using those labels, manual and LLM as a judge. Then we compared outputs and we talked about using failure analysis to drive iteration and improvement. All of this to get an MVE, a minimum viable evaluation framework, a fast, transparent loop for testing and improving LLM apps, even before you have real users. Just a quick note, our next cohort of this course starts in a week, and I'm super excited about it. Stefan and I had a lot of fun in the first cohort, and having people like Nathan be there and contribute so much was so wonderful. And we're super excited about this Builders in Residence program. It's 8 workshops, 2 hours. And then we have guest lectures and that type of stuff. Private Discord channel for discussion. And we've got $1,000 in credits from cloud compute from Modal. We've also just heard from Google's going to sponsor with $300 in Gemini credit. So you'll get to smash Gemini 2.5. And Mistral and Hugging Face are now also sponsoring. So we've got a whole bunch of fun stuff there, which you can check out on the landing page. Because all of you were thoughtful enough to come here and engage, we'd love to give everyone $200 off if you're interested in the course. But if you're not ready for the course yet, just connect with us on LinkedIn and say what's up, because we love having conversations like this all the time. I will follow up with slides and this repository. And I literally just want to show you, this is the LLM as judge, simple LLM judge.py. Okay, it's 200 lines of code with a bunch of comments, right? And you can literally see, this is the prompt I showed you, and that's really the backbone of it. The synthetic data generator file, once I have my personas users, you generate in 80 lines of code, and you can build that with with AI assisted yourself. So there are honestly no excuses now. And I mean that in all kindness. So Nathan, are there any questions in the chat that it'll be worth chatting about? Or
And this is just a little thing of like, for the course that Hugo teaches, this is the kind of conversations in the Discord, but also in the sessions that we have. It's just like, we're all on the cutting edge of stuff. And this is why I personally really enjoyed the course, because there's really robust discussions about, we're doing new things. We're on the tippy top of the edge of everything, and we got to talk and figure it out.
Yeah, I really appreciate that, Nathan. That's something I've got so much out of it. So it'd be great to see as many of you there as possible. But yeah, Nathan from Carvana last time. We had people from Meta and Adobe and Ford and someone from the US Air Force building LLM stuff. And it's a really exciting space to have these types of conversations. But once again, if you can't make it, totally cool. And let's connect on LinkedIn and be in touch. So appreciate you all for the really interesting questions, comments. And I'll follow up with an email with the slides and the GitHub repository and all of that stuff as well. So thanks once again, everyone.
Thank you. Bye.